Welcome. Let us continue with the next point in FMD, that is fatigue. To understand the fatigue, a simple example is given over here. Suppose a cylindrical shaft is available which is subjected to only tensile load. So, on both the sides, tensile load is applied. As you know that the equation of stress will be load upon area, and the failure of this component occurs if it is ductile material. It occurs when the induced stress is larger than yield stress, and if the material is brittle, the failure occurs when the induced stress is larger than ultimate stress. In the second figure, the same component is given, but it is subjected to pure compressive load. So, if pure tensile load is available or pure compressive load is available, the equation is this is the equation which can be used, and we know that when the stress induced increases the yield stress, in the case of ductile material, the failure occurs, and when the stress induced increases ultimate stress, in the case of brittle material, the failure occurs. And when the failure occurs, we know that it gives us notice. When the load increases, as you know that there is cup and cone failure in the case of tensile application. So there is a notice. The cross section reduces and it gives us notice before the failure occurs. Now, what is the meaning of cyclic load? Suppose the same cylindrical component is available, and on this component we are applying both the types of loads. So for some duration tensile load is applied, for the next half duration or the compressive load is applied. So what we are doing, we are applying tensile load and compressive load in a cycle. Say for 180-degree revolution tensile load is applied, for next 180-degree revolution compressive load is applied, and they are changing continuously. So it is cyclic load. So in this kind of application, when the failure occurs in fatigue. This is basically known as fatigue. When the loads are continuously changing in a cycle, it is known as fatigue. See, the failure occurs at a stress value which is less than yield stress. The component is designed according to this, and the failure occurs at a value very less than yield stress if it is ductile material, and if it is ultimate stress if it is brittle material. So the complete design over here will become wrong in this case because of cyclic loading, and it doesn't give us any notice. How the failure occurs, there is a small crack formation, that crack propagates, and ultimately the failure occurs. So without any notice the failure occurs in the case of fatigue. So it is very dangerous, and the total design procedure is different compared to the conventional design procedure in this case. A simple application is shown over here. There is a railway track. Suppose the wheel of wagon is available over here. So that wheel, due to the weight of this wagon, compressive load is applied at the fibers over here, and the nearby fibers are subjected to tensile load. But when the wheel moves in the left hand side, see, suppose this is the new position of wheel, what is happening, the fibers which were subjected to tensile load, now they are applied with compressive load, and the fibers which are available over here, which was initially having compressive load, now the tensile load will be generated. So this is very simple application of fatigue. When a rail wagon passes on the railway track, as the wheel moves on, the fibers which are under the wheel, they are subjected to compressive. These are the fibers which are under the wheel, they are subjected to compressive. The fibers which are nearby the wheels, they are subjected to tensile. So these fibers are subjected to tensile load. As the wheel moves on, the loads are continuously changing from compression to tension, and from tension to compression. So it is very dangerous. The fatigue application is very dangerous, and the failure occurs without any notice. So this is everything about fatigue failure.